This problem will be fairly similar to ones we did earlier involving a table of values, except instead of giving you a table of values, I've given you the graphs of two functions, f of x and g of x. So with these graphs, I do need to tell you, each is meant to be just a collection of line segments connecting the points that I've labeled here. With that information, we should be able to read off the function values and also the derivatives. Now, obviously, at any of these corner points, the derivative of the relevant function is not defined. But everywhere else, the function is part of a line segment. What's the tangent line here? It would just be the continuation of this line. And its derivative would be the slope, which I can calculate just using rise over run. Okay. So I'm going to need to look up those values, not looking in a table, but looking at a graph instead. What we're going to do is using f and g and the function e to the x, we're going to create this new function h of x, which is f divided by e to the x plus 2g of x. And we're asked to find h prime at -1. Okay. So let's see. If we're finding the derivative at a particular point, that's going to be a two-step process. We're going to use our rules for differentiation to find a formula for h prime of x. Once we have that formula, we can plug in -1. Okay, so let's see. Looks like this is a quotient, so it's going to be low e to the x plus 2g of x. That's in parentheses because that whole thing gets multiplied by d high. Now, that's just the derivative of f of x. I'm going to go right to just writing f prime of x. Okay. Minus high f of x, d low, derivative of e to the x plus 2g of x, all over square the bottom, and away we go. Okay, so I want to go back and evaluate any d by dx's that I have. So let's see, that's going to be e to the x plus 2g of x, in parentheses, times f prime of x, minus f of x. Now, in parentheses, derivative of e to the x is e to the x. Here I've got 2 copies of g of x. Constant multiple rule says I'm going to get 2 copies of g prime of x. Notice that is a product. That's 2 times g of x, but it's the special type of product where one of my factors is a constant. So I could use the product rule, but I don't need to. I can use the constant multiple rule just to say I'm going to get 2 copies of the derivative. And usually that's going to be faster. This is still then over e to the x plus 2g of x quantity squared. Okay, let's see. I don't want to erase my pictures because I need them to read off some values. So I'm just going to bump over here. H prime of 1 will equal, what I want to do, and I think I'll erase this top line too, I'm going to copy this formula, but I'm going to replace all of the x's with, oh, I'm sorry, we wanted -1, didn't we? I'm going to replace all the x's with -1. So we will have e to the -1 plus 2 times g of -1 times f prime at -1 minus f at -1 times, in brackets, e to the -1 plus 2 g prime of -1 all over e to the -1 plus 2 g of -1 quantity squared. Okay. So now I need to just read off all of the values that I can from these graphs. Okay. So e to the -1, that's just a number. That's the same as 1 over e. I could write it that way, or I can leave it as e to the -1. Plus 2 times g of -1. Now, as I get these values, I'm just going to write them down off to the side over here, because I can see that might show up again later on. So this was g. Here's -1. I'm looking for the y value at this point. Now, it's a little hard to read because it's not on perfect graph paper, but notice this was a line going from -2, -2 to 0, -1. So we were going over 2 and up 1. At -1, we've gone over 1, so we would have gone up 1/2. So we will be at -1.5 or -3/2. Okay, now that was in parentheses because that whole thing gets multiplied by f prime at -1. So not f at -1, but f prime. Now -1 is here, so we're talking about being on this line segment. That went from -3,1 to 0, -2. So we went down from 1 down to -2 is down 3, and then we went over 3. So that's a slope of -1. Minus f of -1. So now I want the function value there. That's here at -1. And let's see, we said we were coming down 1 over 1. So by the time we're at 0, we're down, or sorry, by the time x is -2, we're at a height of 0. At -1, we're at a height of -1. And then at 0, we're at a height of -2. So f of -1 is also -1. And then that's times e to the -1 plus 2 copies g prime of -1. Don't have that one yet. So -1 is over here. Okay, so we're talking about this line segment. Now, that was the one where we said we were going over 2 and up 1. That's going to give us rise over run of 1/2. All over e to the -1 is just a number, plus 2 copies of g of -1. We said that was -3/2, and that whole quantity is squared. All right, I do have a little bit of arithmetic to do. Okay, I think what I'm going to do here is I'm going to distribute this -1 as I simplify that multiplication. So -1 times e to the -1 is just -e to the -1. Okay. This is going to be -1. The 2's here will cancel, so it's just -1 times -3 is plus 3. That's, oh, I don't need the parentheses anymore because I distributed the -1. Okay. Minus -1 copies of this. That's just going to be plus this, which is e to the -1 plus 1. Those 2's will also cancel. All over e to the -1 minus 3 squared, because those 2's will cancel. Now, on top, I can combine some like terms. I've got e to the -1 and a minus e to the -1. Those cancel. 3 plus 1 is 4. So we will have 4 over e to the -1 minus 3 quantity squared. Okay, a lot of what's tricky about that is just the bookkeeping. And that's just a question of practice and really writing everything out clearly, being very careful about parentheses and brackets and labeling your work correctly.